Hello my dear students, welcome to benzene chemistry classes. Okay, this is the last video of chemical kinetics. With this the topic is over. Okay, in this class I am going to solve the numerical problems on the chemical kinetics, especially on Arrhenius equation. So these are very important for your board examination because most probably every year 3 mark question will come on this concept, Arrhenius equation. So they will ask to calculate what is the activation energy of the reaction and in which temperature the activation energy of the reaction must be this much, like that they will ask. Okay, so ಇನ್ನೂ ಯಾರಾದರೂ ನನ್ನ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ ಅಂತಂದರೆ ಪ್ಲೀಸ್ ಗೋ ಆ್ಯಂಡ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಫಾರ್ ಮೋರ್ ಆ್ಯಂಡ್ ಮೋರ್ ವಿಡಿಯೋಸ್. Subscribe to my YouTube channel and you will get. Okay, let's start with this. Here the rate constant of a reaction at 500 Kelvin and 700 Kelvin. ನಮಗೆ ಎರಡು ಡಿಫರೆಂಟ್ ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಒಂದು ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎರಡು ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಒಂದು 500 Kelvin ಟೆಂಪರೇಚರ್, ಇನ್ನೊಂದು 700 Kelvin ಟೆಂಪರೇಚರ್. So we'll take the lower temperature as T1. That T1 is equals to what? Lower temperature is 500 Kelvin and the higher temperature as T2. This is 700 Kelvin. They have directly given in the Kelvin units. If the temperature is given in degree Celsius, we have to convert degree Celsius into Kelvin. Please remember, because here in the equation we are going to use absolute temperature, not only simply temperature, absolute temperature. And the rate constant at T1 will be K1. K1 is equals to 0.02 per second, and at K2 is equals to, it will be at T2 it will be 0.07 per second. Hey students, by seeing the unit of the rate constant you can understand the order of reaction, isn't it? So these two are the first order reaction. Why? Because the rate constant is given in terms of per second unit, that is none other than first order reaction. Okay, based on this we have to calculate activation energy and the A means what? Arrhenius factor or free exponential factor. We have to calculate these two values. So first we will calculate activation energy. If we know the activation energy, we can calculate the value of A. Okay, let's start with this. What is the formula? Log of K2 by K1 is equals to log of K2 by K1 is equals to EA divided by 2.303 R into T2 minus T1 divided by T1 into T2. This is our standard equation. So directly put the values what they have given here in this equation, we will get the answer. Log of K2 is how much? K2 is 0.07 divided by K1 is 0.02. It is also per second. Both cancels out, units cancels out. Next, this is activation energy. We don't know the value of activation energy. We have to calculate activation energy in this equation. This is EA is equals to EA divided by 2.303. What is the R? R is equals to 8.314 joules Kelvin per mole. Next, here T2 is how much? Joules per Kelvin per mole. It is T2 is temperature 700 Kelvin minus 500 Kelvin divided by 700 into 500 Kelvin. Okay. Next, on dividing this I am going to get log 0.07 divided by 0.02. It will be log of 3.5. 2 ones are 2 threes are, okay, 1 remains. If I take 0, 3.5 EA divided by 2.303 into 8.314 into here 700 minus 500, it will be 200 divided by 7 into 5, 35, 0000. Okay, 20 cancels out. Okay, we know the what is the value of log of 3.5? How to calculate log of 3.5? You know how to calculate this. You have to check Log of 3.5 means two digit number are here. The value will be 0 point something. The log of, you have to see log of 35, not 3.5. You can't get the value of 3.5 in the logarithm table. Okay, so log of 35, you have to see the row, 35th row. Okay, that will be, so the value of log of 3.5 will be 0.544 is equals to EA divided by 2.303 into 8.314 into 2 divided by 3500. Okay, so now we have to calculate the value of activation energy. So activation energy is equals to, these all terms from this side, 0.544 into 2.303 into 8.314 and 3500, the whole divided by this term from this side divided by 2. So the value becomes, on calculating this you are going to get the answer as 18228 joules. So in terms of kilojoules, how can take 1 2 3 10 to the power 1 2 3 18.228 kilojoules. So this is the value of activation energy, the value of activation energy. By using this we have to calculate the another factor A. We have to calculate A. So for that I need to rub this. Please pause the video and write it down. Okay, I'll take the value here. EA is equals to 18228 joules. Okay, now how to calculate this? Here, according to Arrhenius equation, K is equals to A into e raised to minus EA divided by RT. Okay, so the value of K, two values of K are there, K1 and K2. If you take any one, if you take K1, here you have to take the corresponding temperature. If you take K2, here you have to take corresponding temperature. If it is K1, here it will be T1. If it is K2, it will be T2. Okay, so I will take at T1 and K1. I will calculate this at T1 and K1. T1 is equals to how much? 500 Kelvin and K1 is equals to 0.02 per second. Okay, to get the value of A, I have to apply log on both the sides. What happens on applying log on both the sides? Log of K is equals to log of A minus EA divided by RT. Sorry, EA divided by 2.303 RT. So this is also a standard form of the equation we have derived before, isn't it? So if you don't know how to derive, how this equation comes here, please go and watch my previous videos. So now the log of K, I have to take K1. K1 will be how much it is? 0.02. So log of 0.02 is equals to, I don't know the value of log A because I have to calculate that only, minus EA is how much? 18228 joules divided by 2.303 into 8.314 into temperature is how much? 500 Kelvin. Temperature is 500 Kelvin. So now log of 0.02 will be, minus 1.699, isn't it? Why is minus 1.699? Because the log of 0 point something will be, it comes in minus. So log of A minus, on calculating we are going to get the value that is come to be 1.904. because in board examination calculator is normal calc is allowed, we can solve the problem by using the calc. Here the log A is equals to log of A is equals to here it will be 1.904, come this side, 1.904 minus 1.699 699. It is found to be log A is equals to 1.904 minus 1.699. The value will be 0.205. So log, here if log goes that side, it becomes antilog. A is equals to antilog of 0.205. The antilog of 0.205, you can get this directly because antilog is starts from point only. Then after the decimal point you are going to get the values. So therefore A is equals to, the antilog of this much will be 1.603. So this is the answer. 1.603 is the answer. So we got the value of A is equals to 1.603. Isn't it? So like this you can calculate them simply. Okay, pause the video and write it down. We'll solve next one. That is also important. Here these problems, numerical problems, are important for your board examination. Please remember, these are important for 3 mark important questions. Definitely 3 mark important questions will come on based on this equation only, Arrhenius equation. Most of the time they are asked on the Arrhenius equation. Okay, the second one is the rate constant for the reaction. Which reaction is? The ethyl iodide is giving ethane and hydrogen iodide. Here this reaction is decomposition reaction. This is an example of decomposition reaction. Here at 600 Kelvin, this reaction is taking place at 600 Kelvin. T is equals to how much? 600 Kelvin. I am solving this problem now. T is equals to 600 Kelvin. A is 1.60 10 to the power minus 5 per second. This is the rate constant. K will be how much? K will be 1.60 into 10 to the power minus 5 per second. So per second, what does this indicate? The per second indicates that the reaction is first order reaction. The reaction is first order reaction. And also they have given the energy of activation is 209 kilojoules per mole. They have given activation energy is equals to 209 kilojoules per mole. So how we can write it? 209 into kilo means what? 10 to the power 3. 10 to the power 3 joules per mole. Okay. So now what we have to calculate rate constant at 700 Kelvin. We have to calculate rate constant of the reaction at 700 Kelvin temperature. We have to calculate at 700 Kelvin temperature. So how we can write? Log of K2 by K1 is equals to EA divided by 2.303 or T2 minus T1 divided by T1 into T2. Because if I take this as T1 and T2 is equals to how much? T2 will be 700 Kelvin. ಇದು ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಪ್ರಾಬ್ಲಮ್ ಏನಂತಂದ್ರೆ ಅವರು ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದ್ರೆ, they have the value of K2, sorry value of K1 ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ, EA ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ, R ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್, T1 and T2 ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ನಾವೀಗ K2 ವ್ಯಾಲ್ಯೂನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಹೌದಾ? ಸೊ K2 ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಯಾವ ತರ ಮಾಡಬಹುದು? How to calculate this? Let us write it separately. How we can write? Log of K2 minus log of K1 ಅಂತ ಬರೀಬಹುದು ಇದನ್ನ. Log K2 by K1 can be written as log of K2 divided by log of K1 is equals to EA divided by 2.303 R into T2 minus T1 divided by T1 into T2. We can write like this. Okay. So please remember, ಯಾವಾಗಲಾದರೂ K2 ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಕೊಟ್ಟರೆ ಈ ತರ ಸೆಪರೇಟ್ ಮಾಡಿ ಬರ್ಕೋಬೇಕು, ಅಥವಾ K1 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಂತಂದ್ರೆ ಈ ತರ ಸೆಪರೇಟ್ ಮಾಡಿ ಬರ್ಕೋಬೇಕು. ನಮ್ಗೆ ಈಸಿ ಆಗಿ ಬಿಡುತ್ತೆ. ಹೌದಾ? ಸೊ ನಾವು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಈಗ K2 ಬೇಕಂದ್ರೆ log K2 ತೆಗಿಬೇಕಾ ಫಸ್ಟ್? ಇದನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ರೆ K2 ನ ಏನು ಮಾಡಬಹುದು? ಈಜಿಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡಬಹುದು. ಬಿಕಾಸ್ ವಿ ನೋ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ K1 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತು ನಮಗೆ ಈಗ. ಸೊ ಲೆಟ್ ಅಸ್ ಯೂಸ್ ದಿಸ್ ಇಕ್ವೇಷನ್. ವಿಲ್ ಯೂಸ್ ದಿಸ್ ಇಕ್ವೇಷನ್. log K2 is equals to, we don't know, log K2 is equals to ಏನಾಗುತ್ತೆ? ಇದು log K2 ಈ ಕಡೆ log K1 ಈ ಕಡೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? ಪ್ಲಸ್ ಆಗುತ್ತಲ್ಲ, ಇದು ಮೈನಸ್ ಇದು ಪ್ಲಸ್ ಆಗುತ್ತೆ. ಸೊ ಲಾಗ್ ಆಫ್ k1 is equals to how much? This is k1 1.60 into 10 to the power minus 5 per second plus EA is how much? 209 into 10 to the power 3 joules per mole. Joules per mole divided by 2.303 into 8.314 into T2 ಅಂದ್ರೆ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು? 700 ಕೆಲ್ವಿನ್. 700 minus 600 divided by 700 into 600. Okay. So log of K2 is equals to so what is the value of 1.60 into 10 to the power minus 5? ಎಷ್ಟಾಗುತ್ತೆ ನೋಡ್ರಿ ಇದು? 1.60 into 10 to the power minus 5. The value comes out to be minus 4.796 plus ಇದನ್ನೆಲ್ಲನೂ ನಾವು ಮ್ಯಾಥಮೆಟಿಕಲಿ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ, so what I am going to get is 2.599. ಇಷ್ಟು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ, 2.599. ಇದೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಇಷ್ಟು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಸೊ ಲಾಗ್ ಆಫ್ k2 is equals to ನೋಡಿ ಲೆಸ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಉಳಿತು ನೋಡ್ರಿ, minus 4.796 plus 2.599, that remains minus 2.197. ಹೌದಲ್ಲ, 2.197 ಬರುತ್ತೆ. k2 is equals to anti-log of minus 2.197. So you know how to calculate anti-log of negative numbers, isn't it? So if you don't know how to calculate anti-log of negative numbers, please comment me and I will solve it in the next video. ನನಗೆ ಕಮೆಂಟ್ ಮಾಡಿದರೆ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಅದರ್ವೈಸ್ ಐ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ್ಯಾಟ್ ಯು ನೋ ಹೌ ಟು ಸಾಲ್ವ್ ದಿಸ್. ಓಕೆ, this will be k2 is equals to how much? Minus 2. The answer will be comes to be 10 to the power minus 3 in terms of 10 to the power minus 3, and you have to take the anti-log of the number, that will be 6.36 into 10 to the power minus 3 per second. This is the answer. 6.36 into 10 to the power minus 3 per second is the answer. So like this you can solve easily, and this is the problem. The specific reaction rate of a reaction quadruples. See here, idana nanu homework anta kodini, take it as homework question it is. You have to solve this question on your own and send that answer in the comment. Okay, comment alli ಏನು ಮಾಡಬೇಕು, answer na send ಮಾಡಬೇಕು. If you don't know, if you don't get how to solve this, and also tell me that I will solve. Okay, here ಇದರಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದ್ರೆ, it's very simple. The specific reaction rate of a reaction is quadruples when temperature changes from 30 degrees Celsius to 50 degrees Celsius. Temperature is given in degree Celsius. We have to convert it into Kelvin. Degree Celsius ಕೊಟ್ಟಿದ್ದಾರೆ, Kelvin ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಥಿಂಗ್, ಹೌದಾ? ಸೆಕೆಂಡ್ ಥಿಂಗ್, ಇದೇನಿದ್ರು ಮೀನಿಂಗ್ quadruple means increases by 4 times. See here, k1 ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತಲ್ಲ, here k1 is at 30 degrees Celsius. If temperature increases to 50 degrees Celsius, that becomes, ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, that becomes 4 into k1 ವ್ಯಾಲ್ಯೂ ಇರುತ್ತಲ್ಲ, k2 ಎಷ್ಟಾಗುತ್ತೆ ಅಂದರೆ k2 is equals to 4 times of k1. ಟೆಂಪರೇಚರ್ನ 30 ಡಿಗ್ರಿಯಿಂದ 50 ಡಿಗ್ರಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ k1 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಇರುತ್ತಲ್ಲ ಅದು 4 ಟೈಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಏನು ಕರಿಬೋದು, ನಾವು k2 ಅಂತ ಕರಿಬೋದಾ? k2 is equals to 4 k1. ಸೊ ಇಷ್ಟು ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಮಗೆ ಇದು ಪ್ರಾಬ್ಲಮ್ ಈಸಿಲಿ ಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸಾಲ್ವ್ ಇಟ್ ಈಸಿಲಿ and read well. Thank you so much for watching.